Welcome to Cyberpunk room build series. This time I'm making a keyboard mount out of aluminium using the Makera Z1 desktop CNC machine. The mount attaches to the custom desk that I made out of 4040 aluminium extrusions in the first episode. The top plates of the mount attach directly to the PCBs of the wireless split keyboard. In the future episode I might make a full bottom case for the keyboard and battery using the CNC milling, but this time I'm just learning the basics of this machine and I need to start really simple. I will show you all the mistakes I made while using the CNC for the first time and designing the parts for milling. I will also share the issues I encountered with the Z1 machine and how I worked around them so far. So let's start with the unboxing. Makera sent me this machine for free with a bunch of add-ons which I will not be using in this video. Since I've never used a CAM or computer-aided manufacturing software before, I really needed to catch up on the basics fast, since it's very much different from the 3D printing workflow I'm used to. The fastest way to learn for me is always hands-on in a project while messing up or debugging issues. To keep the motivation high, I really wanted to make something I actually wanted to use, and this keyboard mount was on my list for a long time. And even more importantly, the mount can be simplified to only 2 parts attached with a couple of M3 screws. Let's check out what all the boxes contain. So this is the toolkit, some bits and the mounting points. Then all the additional bits and the collars. Materials and accessories contain all the probes, including the 3D wired probe and the new version 2 Z probe. The low profile vise was one of the add-on items that I really wanted to use right away because it seemed super useful and time-saving compared to the standard way of mounting stock material to the base plate. Since I'm planning to do more projects with aluminium extrusions, I ran my initial tests with a piece of old 4040 extrusion to see how the machine can handle the irregular shapes as a stock material. After the initial boot and the firmware update, the machine was ready to use. Before starting the actual milling process with the generated G-code, there are a couple of optional procedures you can do for safety and better results. Those include probing, which checks the top Z dimension of the stock material at one point, and auto-leveling, which checks the Z axis over the whole area of the upcoming job, similar to what the 3D printers do. My mistake was not realizing that the software always assumes the stock material has a flat top. This implies that you cannot do the auto-leveling procedure using the irregularly shaped stock like I'm doing here. You can only do Z probing at one point and plan your job around that. My second mistake was not carefully planning the Z depth of every hole. Even though the machine calibrates the Z dimension on every bit change, it does not automatically check in your G-code if the planned drilling paths are too deep for the current bit. This is a missing feature in my opinion that would be relatively easy to implement, and I would expect it in one of the upcoming software updates. I had 2 goals with this first CNC project. First, make a useful 2-part item, and second, learn how to make the threads in the milled holes, because that's something I really think is useful and different from 3D printing. The keyboard I have is the Corne Choc Pro Bluetooth version, so it's a split keyboard running on batteries and it's wireless, also using Bluetooth protocol. I precisely measure the hole spacings on the PCBs so I can make this bottom plate. And to actually validate it, I did some 3D printing on the rough settings just to check if my spacings and holes are spot on the part. After that was done, I started the process of learning the CAM and how to actually transfer this 3D design into the CAM software and what steps I need to take to actually produce the part I want. It was interesting to learn that you're not supposed to add any chamfering or contouring in your 3D design, because those are interactions with your model and the stock material that you add in the CAM software later. Also, tabs for the contours and similar things, just as well as threads, of course, are things that you do not add in your 3D model, but only later in the CAM software. Another thing that I found really stupid is that you cannot leave empty holes in your model, because then you don't have a bottom surface to select in order to generate drill path or a pocket milling path later. So you always have to add a thin bottom below your 3D model in order to have those surfaces available in the CAM software. This again, I believe, is just a missing feature at the moment. What you're seeing here is blue paths going slightly below the stock material and below the model. So this is a little manual modification in the path depth in the CAM software that you need to do if you want your drill holes or pocket holes to go completely through the material. Because otherwise, it's by default, it only goes to the exact bottom you selected based on the surface of the model. Another critical mistake I made a couple of times is forgetting to add tabs when creating a contour path. Contouring is basically cutting the outside edge of your part, and the tabs are thin parts at the edge that should be skipped so that your part stays attached to the stock material so it doesn't get displaced or moved during the final operations. Without tabs, my part would fall through to the bottom of the vise, and then you cannot do any corrections or additional passes on top, like adding some chamfering or finishing touches. Another obvious mistake in hindsight I made was simply using the bit that is wrong for the stock material. In this case, I used a drill bit that looked strong enough for the metal, and it looked yellow like other metal drill bits I had for the handheld drill, but it actually was the worst type of bit you can use for drilling aluminum, and it broke right away on the second attempt drilling the hole. So be really careful, especially distinguishing the bits for the metal and non-metal bits. This is the shot of creating threads on the side of one of the pieces, and this is the final version of the bottom plate below the keyboard. The process of creating these parts was much slower and more painful compared to 3D printing process, but the finished parts are definitely worth it. The feel and strength of the metal, the perfect threading for the screws, the precise dimensionality and how it all fits together is just on another level. One missing feature that really annoyed me was the inability to create larger chamferings using smaller chamfering bit. This is available in other software packages like Fusion 360 using the bore path feature. But in Makera Studio or Makera CAM software, this feature is simply not available, so you're stuck with only smaller chamfers for which you already have the appropriate bits, and that's it. In this build I'm using M8 screws, which are relatively large, and it was unacceptable to have them stand out without larger chamfers, so I had to fall back on using the manual drill to create the chamfers this time. They were still not perfectly flush at the end, but I guess I also need a larger bit for the manual chamfering. The finished mounts were surprisingly solid and strong. I'm not sure what I was expecting, but using such a thin 3mm aluminium plate for the bottom mounts, I didn't have much of the expectation, but it turned out super strong. Thanks again for watching to the end. I really appreciate it, because without all these views I could never have gotten my hands on this CNC machine, which was really fun to learn and to use in this project, and hopefully will be even more of a useful tool for all the future projects I plan. So please stay tuned, and see you in the next video.